வணக்கம், இது நம்ம 5 minutes clips. So today we have to see the welded sample testing and assessing the quality. This testing and sample assessing quality is common to all the categories, not only for welding. If you are working in composite or metallic materials, ceramics, etc., some of the test will be applicable to this category also. So most probably if you are going to study their mechanical characterization, these things are very important, and I think strongly believe that you have seen these type of studies in the strength of material lab. Okay, let us go and check how they are correlating with our samples. So there is two type of major categories. One is destructive testing, another one is non-destructive testing. Destructive testing means we going to conduct some test. After that the sample will be broken into number of pieces or 2 pieces. We cannot reuse the sample if it is okay. In non-destructive test, you simply say we are not going to break the samples. We are going to check is there any flaws or defects are available in the samples. If there is no defects, we can use the sample for further applications. If we found any defects, we will check whether it's permissible or not. If it is not permissible, we are going to throw this into garbage. So here you can see under destructive test we have 4 category, and similarly non-destructive testing we have 5, but more than that also we have, but these 5 are commonly we are using. And destructive test, first one is the tensile test. Okay, so tensile test, you can take any metallic, non-metallic, anything depending upon the thickness. Their size may be vary. Miniature sample for 100 mm length also available, or if you want you can go for 200 mm length also. It is all depend on the thickness. Okay, so in this slide I have shown figure 1, figure 2, figure 3. This is the longitudinal tensile test. You can see center portion is the weld, this is base metal. So if you want to check the strength of the weld, and not only strength, if you want to check how it is good or not, if you want to run any simulation, if you want to give the exact property of the weldment, you have to take the longitudinal tensile test specimen. Then you have to conduct the tensile test. This specimen is shown in the last one. As you can see, it's a longitudinal specimen, right? Another one is the transverse specimen, where base metals are having the holding portion and we have a weld portion in the center, as you see in like this. Okay, after that we have to hold this specimen in the UTM, and you know that what is the strain rate and other things for your specimen you can set, and you can conduct the exam. And we will always checking their quality with the base metal, right? If your welding procedure everything is good, it will give more than base metal strength. Nothing to worry, I am sure it is good. Another thing is 3-point bending test. In 3-point bending test, 1 point will be over here, 1 point will be over here, another third point will be act as a punch. There is 2 types of bending tests are available. One is face bend, another one is root bend. If base bend test, the face should be come down. In root bend test, root will be in bottom side position, so nothing to worry. You can check here, there is some cracks are appeared over here, and here nothing, here nothing. If these 2 are passed, if you want to see any internal flaws are appeared, you can go for radiographic test, that we will discuss later. That next one is the micro hardness test or hardness test. You can see these 2 are Rockwell, and this thing are not micro hardness, but Vickerness hardness is a micro hardness test. We are because we are using diamond indenter to apply the load, and we have to check how much penetration it was made. That diagonal portion we are measuring. From that we are going to identify the hardness of the material. This is always used in the industry purpose, but in your laboratory purpose we are using Brunel and Rockwell. In Rockwell we have minor load and major load. First we have to apply the minor load to make one small penetration. After that we have to apply the major load, and after that we are using some formulas and we are calculating how much hardness it is. Similarly for Brunel we are using one ball, and we are going to apply some forces. Then we have to identify what is the diameter, that means how much depth it was went. After that we are putting the same formula, and we are going to identify what is the hardness for that corresponding material. Next one is the impact test. Impact test, this test will not apply for thin sheets, only for thicker job. As you can see, I think more than 10 mm thickness of the sample you are holding over here. There is 2 types of test is available. One is IZOD, another one is Sharpie, I think. IZOD is nothing but if you are putting your workpiece in letter I, alphabet letter I like this, it will IZOD. If you are putting like this, it will be Sharpie, right? Next, we are going for next topic is non-destructive testing. Non-destructive testing, typically we are having only 4, and that's enough because most of the time we are using these 4 only. You can see first one is the liquid penetration test, is nothing but first we have to clean the surface, right? After that we have to put the penetrant, right? We should allow it for 5 to 6 minutes. Okay, then if you want immediately, if you want, you can remove the excess penetrant. So if there is any flaw, the penetrant will go and occupy the space. Okay, after cleaning, surface level cleaning only we are going to do. So if it is getting inside the flaw, it will stuck. Then you should apply the developer, right? Then wait for 5 to 7 minutes. Right. So the reaction will be taking place between the penetrant to the developer, so that area we will get some color indation. Okay, through this only we are going to identify. This liquid penetration will helpful to find out the flaws in the surface level, not in the volumetric level. Got it? So in the surface level, if any porosity, cracks, anything up, we can easily detect. And next one is the magnetic particle testing. And the magnetic particle, we are using 2 magnets, south pole and north pole. In between we are going to put iron oxide powders and we are going to move. So we are going to check any deflection is available or not. If any deflection is appeared, we can see that it will be looks like only. So the bath flowing, but there is a flaw, so it will not go like this. So iron oxide powder we have placed, right? So in between it will go by using the iron flux, if it will move. It may be most of the time is a temporary magnet. As you can see, there is a wire is coming. Whenever you are passing the current, it will be magnetized. Okay, simple technique. These 2 for surface level defect. So what about the volumetric level? Yes, absolutely, we are having 2 more techniques, that is radiographic and ultrasonic. In radiographic we are using radiating element, something iodine, cobalt, etc, etc. If you want, you can use x-rays also, not a problem. So if you have an object like this and have one small condor and one internal flaw, that is hole is available at somewhat distance, so we are giving one photoionic film. The concept is if the radiating element is passing through a photoionic film, it will damage the film. Okay, so you can see here we have some thickness as a capital X, and here is the X1, some material was removed, and here some material was removed, so we'll take this overall thickness is X2. Okay, so we are going to open the radiation element, so the radiation rays will pass, and you can see because of the reduction area it was severely damaged. Similarly here also it was severely damaged, so we can identify that flaws are available over here and over here. If you want to check where it is exactly, then you should go for ultrasonic test. Ultrasonic test, we are having one ultrasonic probe which can be act as a receiver as well as sender, right? So the how long it took and what about the strength of the received signal, that will give the some peaks over here, peak UR something peaks will give. So normal general we are a signal we have created like this. Due to the flaw, it was appeared like this only, so we can easily identify. There is a small formula we have, so by using that we can preciously identify where the flaw was appeared. Depth, okay, so higher thickness we can use this thing, and only disadvantage is the probe. Here is the probe, we have to use some lubrications over the surface so that we can easily protect the probe from the damage. And here we have a radioactive element, that's an we are afraid about the radioactive element to handle it, so we should be take care. We have some badges, some indicators, we should hold it in our pocket so that it will tell how much radiations you are absorbed. Okay, we should take care. So both things will be very helpful for you. So why we are always looking towards welding, there is a lot we can cover by using welding. If you want to do any final year project, you can choose any field and you can apply, not a problem. So hope you guys are enjoyed this lecture, and thanks for watching. If you have anything, you can make a comment.